Hi Math 2 students. Today we are going to continue the lesson on using the right triangle trig functions. So previously we learned how to solve for a side on the triangle and set up trig ratios. Today we're going to talk about how we find the angle in a right triangle. All right. So before we get started, the way that we undo operations, right? So if you think about, like, let's say if we had x plus 2 equals 10, right? To undo the plus 2, we do a minus 2, right? And we usually say that that's like the opposite. And the mathy way to refer to that is that is the inverse operation. So the inverse of a plus 2 is a minus 2, all right? So to undo trig functions, we are going to use their inverse, okay? Their opposite, all right? So for sine, the opposite is just sine inverse. Cosine, opposite is just cosine inverse. And tangent, of course, the opposite is tangent inverse. And you'll see these buttons on your calculator. All right. So let's go ahead and take a look here at example E. If we go ahead and mark the angle of interest, right, the one with the x, that's our angle of interest here. All right. And of course, we're going to go label our sides in relation to our angle of interest. Across, we have our opposite side. Across from the 90-degree angle, we have our hypotenuse. And then our remaining side is going to be our adjacent. All right, so if we look, we have our opposite and we have our adjacent. So opposite and adjacent is going to be tangent. Now, previously we either said, like, you know, tangent of theta, tangent of A, tangent of an actual number, you know, like tangent of 50. Now here we're going to put tangent of x, right, because that's what we're solving for. That's what that angle is equal to. And tangent of x is going to be equal to our opposite over adjacent, so 11 over 7. All right, so from here, we need to work to get our x by itself. Now, it's actually pretty easy to get the x by itself. What you have to do is the inverse function. So when you do tangent inverse of tangent of x, all right, these guys cancel each other out and you're just left with x. So what you're going to want to do is take the tangent inverse of both sides. All right, these tangents cancel each other out and we get that x is equal to tangent inverse of 11 over 7. All right, now, this is a lot of writing. I am perfectly fine with you going like from here to here, or if you just want to go straight to the inverse function because you know you're solving for an angle, you're more than welcome to do that. All right, but I'm just showing you why we use the inverse function, and it's to undo the tangent, undo the cosine, undo the sine. So we're going to go ahead, go to our calculators, and friendly reminder, make sure you are in the right mode. You need to be in degree mode. I am in degree mode. Now, to get the inverse function, okay, you have to use the second button. Do not just do, like, you know, tangent and then do, you know, the caret with the -1. Don't do that. We want to use our second button and get our sine inverse, cosine inverse, tangent. You'll see that those guys are right above the normal sine, cosine, tangent. So we're going to click second, and then we're going to click tangent, and that's going to give us our tangent inverse. And we need to do tangent inverse of 11 over 7. All right. And what that does is that gives me the angle measure of angle B there. All right. So we see that x is going to be equal to 57.5 degrees. All right. So let's go ahead and take a look here at example F. We're going to mark our angle. And then let's go ahead and mark the sides associated with that angle. So we should have our adjacent, our opposite, and our hypotenuse. So we can see in relation to this x here, we have our adjacent and our hypotenuse, right? Which trig function is associated with adjacent and hypotenuse? That's going to be cosine, right? So we are going to set this up as cosine of x is equal to our adjacent over our hypotenuse. All right, and of course, we want to solve for x. We want to get x by itself. So what we're going to do is we just take the cosine inverse of both sides, which gives us that x is equal to cosine inverse of 5 over 8. So we can go second cosine 5 over 8 and that's going to give us 51.3. So x is equal to 51.3 degrees. All right. Now, let's go ahead, take a look at example G. Now, again, they're having us solve for an angle. So let's try this time just to go straight to the inverse function, okay? We know that if we're solving for an angle, we got to go to the inverse function. The only time where you're going to be solving for an angle where you won't go to the inverse function is like if you have another angle already given to you. Like, you know, if they told us that this was 30, we could look and be like, oh, well, if that's 30 and this is 90, this has to be 60, right? But that's the only time in these kinds of problems where you're not going to need to do that. So we'll go ahead, mark our angle of interest, and we have our opposite, our hypotenuse, and our adjacent. So if we look at x, we have the opposite and the hypotenuse. So what trig function is associated with the opposite and hypotenuse sides of the right triangle? That is going to be sine. So remember I said we're going to go straight to the inverse, so we're just going to do sine inverse of our opposite of our hypotenuse, which is 17 over 41. We're going to do second sine inverse of 17 divided by 41. Click enter, and we get that x, our angle here, is going to be equal to 24.5. All right. So hopefully not too terrible. Actually, in my opinion, finding the angles is actually easier because you don't have to worry about the multiplying and dividing thing like you do with the sides. It's the same thing every time. All right. So let's go ahead and try two of these problems here. So if we look at example, or this first problem here, right, we can see that they want us to find two sides and an angle. All right. Now, to find this angle, we don't have to use the trig functions. Why don't we have to use the trig functions? Well, we have that this is 90, and we have that this is 49, and we know that all three angles are supposed to add up to 180 degrees. So we can just do 180 minus 90 minus 49. Excuse me, that gives us that angle M is equal to 41. All right. Now, you could put the 41 in there and then make that your angle of interest because there wasn't any rounding involved here. But let's just mark our 49 as our angle that we are using as kind of our base point here. And we're going to go label the sides in relation to angle 49. All right. So we have our opposite, our hypotenuse, and our adjacent. So with this in mind, go ahead. I want you to try and solve for A. So to solve for A, we have opposite and hypotenuse, right? So we're going to do sine, and that is going to be sine of 49, and that's going to be equal to our opposite, which is A, over our hypotenuse, which is 30. All right. So then from there, we can go ahead and get A by itself. We're going to multiply both sides by 30, and we get that A is going to be equal to sine of 49. So we're going to do sine 49, which gives us, ooh, hold on, 30 sine 49, sorry. A is equal to 30 times sine of 49. My bad. So 30 times sine of 49 is going to give us 22.6. All right, so that's our answer for A. Now let's go ahead and see if we can find B. So if we look, we have our adjacent and we have our hypotenuse, right? So that's going to be cosine. So we're going to do cosine of 49 is equal to our adjacent B over our hypotenuse, which is 30. So go ahead, solve for B. So B here is going to be 30 cosine of 49, which gives us 19.7. All right. Now let's go ahead and take a look here at example 2. All right. So here they gave us two sides, and we have to solve for the third side. You could use trig to find that, but you know what we're going to do is we are going to use Pythagorean's theorem, right? That tends to just be easier. If you've got two sides of a right triangle, go ahead, use Pythagorean's theorem to find the third side. So we've got, we'll say A, and C, right? Or A, B, and C, sorry. So we've got 11 squared plus 13 squared equals C squared. So that is going to be, we know 11 squared is 121. We know 13 squared is 169. So 121 plus 169 gives us 290. All right. So we have to go ahead and break that down. Well, I guess first we have to go ahead and take the square root of both sides. So we're going to go ahead and we get that C is equal to the square root of 290. Now you could go ahead and try and break that down, but there actually there aren't any perfect squares that go into 290. Like 29 and 10 go into there, and you could go ahead and try the perfect squares, but I'll save you some time. There's not going to be any perfect squares that go into that. So we know that C is equal to the square root of 290. All right. So we can leave that guy there. Oh, I guess I could just leave my work too. I don't know, I'm erasing it. And we need to solve for our angles, right? So before we had two angles, so we were able to do like 180 minus, but here we only have one angle. We only have the 90. So we have no choice but to use our inverse functions. So let's solve for n first. All right. We're going to go label our sides. We have for n, opposite, adjacent, hypotenuse. Okay. So we're going to go ahead and just use the 11 and the 13. We could technically use the root 290, but this is a lot easier. So we've got opposite and adjacent, so we will do tangent inverse, because we're solving for an angle, of 11 over 13. So I'm going to do second tangent inverse of 11 over 13. And for n, I get 40.2 degrees. So you could go ahead and at this point, honestly, it makes the most sense if we know that that's 40.2. We could just do 180. Whoops. Minus 90 minus 40.2. And that's going to give us 49.8. So that means that m is 49.8. If you solve for m first, that'd be totally fine. You would have gotten 49.8, and then you could have done the 180 minus to find n. All right?